In 2012, Montana tipped the scales and reached a state population of 1 million residents. It's not just Montana that's growing. Our current world population is 7.6 billion and is projected to reach 9.8 billion by 2050. Estimates project that crop production will need to roughly double in order to feed this additional 2 billion people. National Geographic suggests a 5-step strategy to meet the increased food demand. This includes freezing the agricultural footprint, growing more on existing farms, using resources more efficiently, shifting diets, and reducing food waste, which is what I'm going to be talking about today. Did you know that roughly 1/3 of the food produced in this world for human consumption is wasted each year? If you're wondering how to sustainably feed these additional 2 billion people, food waste might be a good place to start. So if we look at food waste in America today, the majority, in fact roughly 33%, is comprised of fresh fruit and vegetables. Food waste is produced throughout the entire food supply chain, from farm to fork. But why do we waste food? Some of the most common reasons include deterioration of quality over time, overproduction, excessive purchasing, and lack of knowledge. What if I told you that there's an existing technology that can support reduction of food waste, specifically food waste of fresh fruits, vegetables, meat, poultry, and grain products? That technology is called food irradiation. Food irradiation, otherwise known as electronic pasteurization or cold pasteurization, is a process that exposes food to a source of ionizing radiation to kill pathogens such as bacteria, parasites, insect, and mold. The radiant energy breaks chemical bonds and damages DNA, killing microorganisms and inhibiting cell reproduction. This technology has been in use since 1963, when the FDA first approved it to kill pests on wheat and flour. In fact, NASA's been using this technology since the 1970s to make food safe for astronaut consumption in outer space. There are 3 types of radiation approved for food. Gamma radiation, which is sourced from radioactive cobalt-60 and less popular cesium-137. This can penetrate up to 3 feet deep and is best for bulk processing. This is not the same as nuclear power plants, where isotopes produce nuclear waste. Instead, over time, cobalt-60 decays and becomes less radioactive. Next is X-ray. This uses a high-energy stream of electrons that are reflected off of a heavy metal plate to create X-ray. This technology can penetrate 3 feet deep as well. And lastly is electron beams, or E-beams, which uses a stream of high-energy electrons that are propelled at 99% the speed of light directly at food. This has the shortest penetration depth and can only reach about 3.5 inches deep. Both X-ray and E-beam technology do not involve radioactive substances. The amount and type of radiation depends on the type of food, its condition, whether it's fresh or frozen, the thickness of the product, and the packaging that it's in. Taste and texture may be altered if too much irradiation is used. Therefore, this process is tightly regulated. Irradiation doesn't work well on all foods though, particularly on high-fat foods such as dairy products and some nuts, as it alters the taste and odor too much. So at this point, this might be sounding a little scary, and you might be wondering if this is really safe. Well, the entire process is done in specialized facilities that are regulated by the FDA and OSHA. All food processed with irradiation carries a Radura symbol and a statement indicating irradiation was used. The symbol is not to warn customers, but to simply give them a choice. Food is never in contact with radiation and only the energy that's produced by it. Therefore, the process does not make food radioactive. Just like your bags and the contents within them do not become radioactive when you go through the airport security. As a future dietitian, I constantly think about the nutritional value of the food we eat and if processing can have a detrimental impact. When food is exposed to low doses of irradiation, nutrient loss is not significant and is comparable to foods that have been cooked, canned, frozen, or pasteurized. Some studies have shown that thiamine and ascorbic acid concentrations are slightly reduced by radiation, but again, this amount is minimal. Research into the effects of food irradiation have been conducted for over 50 years by various public health agencies around the world, and there has been no evidence that suggests this process is dangerous. A few organizations that have approved the support of food irradiation include the FDA, the CDC, the USDA, the World Health Organization, the Academy of Nutrition and Dietetics, and the American Medical Association. 2 years ago, my husband and I went on a ski trip to Canada. Before we left, I spent time grocery shopping and preparing meals for the road. 8 hours into our trip, we reached the Canadian border. We pulled up to a tiny one-man hut at the border crossing where we were asked for our passports and if we had any fresh produce with us. I divulged that we did, and the crossing guard promptly asked me to give up the citrus fruit that I had on board. I opened up this large box that was labeled biohazard, located just outside of the hut, and added my citrus to this heaping pile of food that others had left behind too. As we drove past the border into Canada, it sank in with me that there must be so much food that is left behind and sent to the landfill at border crossings. In this situation, if food irradiation was used to kill the insects on my citrus, we would have been able to cross the border without wasting our perfectly fine food. Using irradiation to help control insects is just one way we can use this technology to our advantage. In addition, we can use it to preserve food and to increase shelf life by delaying sprouting of products such as onion, garlic, and potatoes, by delaying ripening of fresh produce. We can use it to help control mold, fungus, and those insects I was just talking about. It can be used to sterilize foods so products can stay on shelves for prolonged periods of time. It can also be used to sterilize foods for the immunocompromised. We can use it to prevent foodborne illness, such as E. coli and salmonella, and to reduce the need for toxic chemicals and fumigation on produce and meat. It's great that we have this irradiation technology at our disposal, and I'm suggesting that we harness this resource and use it in a grander scale to help prevent food waste. Currently, food irradiation has been approved in 41 countries. There are over 150 facilities worldwide that treat more than 30 different types of food. Now in the US, the FDA has approved radiation on products such as beef, pork, poultry, crustaceans and shellfish, fresh fruit and vegetables, lettuce and spinach, seeds for sprouting, shell eggs, and spices and seasonings. If this technology has been around for decades and has such impactful applications, why don't we see it used more today? One reason is public acceptance. People's perception regarding the word irradiation is not always positive, and many of them have concerns about long-term safety. Another reason is cost, both the cost of building new facilities to treat this food and also the increased food costs that's associated with this processing technique. There's no one solution to feeding 9.8 billion people, and a collaboration of ideas and processes will be necessary in order to make this task sustainable. Food irradiation is just one way that we can reduce food waste on our planet. This is not the only solution to feed our growing population, but can be one way to contribute. For this to become reality, there needs to be an increase in public awareness and education of what irradiation is and how it impacts the food we eat and our entire food system. Thank you.